the right hand side, aircraft is what? So like this, your aircraft is showing a right hand turn and the ball is also deflected to the right. So when both the needle and the ball show right hand turn, that means aircraft is slipping to the right hand side, slipping to the right hand side. Now, whenever you're turning your aircraft, the needle should indicate left turn or right turn. Needle means the miniature aircraft symbol, this one. And the ball must remain in the center of this inclinometer. Only then and then we can consider your turn to be a coordinated turn. If your ball is out of the central goal post, either to the right or to the left of it, we call it skidding, slipping or skidding respectively. Right now, in this case, it is slipping because it is fallen to the inside of the turn. So you are turning to the right hand side. You are you are turning to the right hand side, and this ball has also gone to the right hand side. That means, let's say this is the center of your circle, and this is the circle. You are turning right hand side. You are turning right hand side. So this ball is also drawn towards the center of the circle to the right under the influence of centripetal force. Under the influence of centripetal or center or center directed force, inward directed force, right? So this happens because what are the causes? Causes are first too much bank, too much bank, okay, and insufficient rudder pressure, insufficient rudder pressure. So what are the solutions? Solutions are to decrease your angle of bank. If you have banked your aircraft to 25 degree, 30 degree, let's say, you will decrease that angle to a new bank angle of 20 degree, 15 degree, whatever. So try decreasing your bank angle, decrease bank angle. Second, right rudder. Now here the ball has gone to the right hand side, so you will apply right rudder pressure. If it moves to the left, apply left rudder. So right rudder pressure. Okay. So these are the solutions. So when you apply the right rudder pressure, okay, the ball will automatically come in the center. And when you decrease the bank angle of your aircraft, when you decrease the bank angle of your aircraft a little bit, as required, the centripetal force, which is inward directed force, it will decrease in value, and centrifugal force, which is outward directed force, that will increase in value. Okay, so a decrease in one is accompanied by an increment in other force. So this centrifugal force will draw or pull the ball towards it, towards from the center towards the outside of the center. And finally, when a balance is struck between centripetal force and centrifugal force, the ball will remain in the center of the goal post. Okay, so when both needle and ball of a turn and slip indicator are displaced to the right hand side, aircraft is turning right with insufficient bank, turning right with too much bank, turning left with too much bank. So it is turning right with too much bank, extra bank. Next. In a primary radar using pulse technique, pulse recurrence frequency determines minimum range, beam width, maximum range. So correct answer is option star B. Do watch all my radar lectures. I have solved all the questions from basic radar principles, secondary radar, DME, airborne weather radar from Oxford, Keith Williams also. Uploaded them to my channel. You can find them in the separate playlist that I have made for Oxford GenNav, RK Bali Radio Nav, Oxford Radio Nav, Keith Williams Radio Nav. I've also marked important points from secondary surveillance radar, airborne weather radar, this basic radar principles chapter from Oxford, and uploaded them to my YouTube channel. So you can watch those video lectures. You can mark the important points in your textbooks, and you can revise those important points again and again for your exam. Right? So I have explained that many times in those video lectures. The maximum range is proportional to pulse recurrence frequency. That means whatever pulse you send in the direction of the target, you must wait till that pulse goes to the target, strikes the target, and gets reflected from it. After that, you are going to send another pulse, a new pulse. If you send a pulse just after sending the previous pulse, even before that previous pulse goes to the target, gets reflected from that target, so there will be confusion between these two consecutive pulses. So there must be sufficient time difference or time space between two pulses such that the first pulse goes to the target, strikes it, and comes back. After that, you send a new pulse in the direction of the same target. So maximum range is proportional to PRF. It's inversely proportional to pulse recurrence frequency. Minimum range, minimum range is proportional to width, pulse width. Okay. Next, beam width. Now, resolution, that is azimuth resolution, depends on beam width, half the beam width. That is that. Question 73. Which of the following disturbances is most likely to cause the greatest inaccuracy in ADF bearings? Now, coastal effect. What is coastal effect? Let's say this is the coastline. What is a coastline? It is the demarcation boundary between land surface and the sea or ocean water surface, right? So here is your water surface here. On this side, on the other side, we have a solid land surface. We have land surface. I'm going to take two NDB stations. One is close to the coastline and one is well inbound. Okay. So let's take one NDB station is here and another is very well inbound towards the city. Okay, not near the coastline. Now here there is aircraft. Let's say. So now if it's tuned to an NDB station number one, it's tuned to an NDB station number one. This is NDB station number two. So whatever radio signal is transmitted by this NDB station, it will go like this towards the coastline. When it meets the coastline, it gets refracted. That means it bends instead of going straight like this, it will bend away from the normal and go somewhere like this or somewhere like this. That is the drawback. This is called coastal refraction. So when the radio signal travels from the NDB station, which is well inland, towards the coastline, it bends away from the normal and goes away. So that means if there is any aircraft, let's say there is any aircraft over here, receives this NDB signal from this NDB station 1, okay, instead of thinking or instead of tuning to the NDB station number 1 or instead of getting a direction or bearing from this NDB station 1, the ADF equipment on board will think that this radio signal is coming or originating from a station which is somewhere else. Instead of tracing this radio signal to the correct NDB station number 1, it will think that this radio signal is originating from some radio beacon which is over here, NDB station number 3. So this aircraft will start tracking its path towards that NDB station number 3. So this is the error that is produced by coastal refraction. Okay, so instead of getting a track towards the correct NDB station, it will get information, or the ADF equipment on board will think it is getting radio signals from some other NDB station which is at this angle. Okay, so this is called coastal refraction. Coastal refraction. What is the solution? How to minimize coastal refraction? That means fly at high altitudes. Second, use an NDB station. Use an NDB station that is close to the sea coastline. Third, uh, third, the radio signal must travel 90 degree or perpendicular to the coastline. So now this particular radio signal travels at an acute angle. So that's therefore it suffers refraction. But if the radio signal travels straight, there won't be any refraction. Okay, so this is one error, coastal refraction. The second is quadrantal error. So let's say this is your aircraft. Okay, this is your aircraft. Here are the wings of your aircraft. This is the north datum. Now, along the fore and aft axis, which is the longitudinal axis of your aircraft, around this fore and aft axis, which is the longitudinal axis, and the lateral axis, there won't be bending along this longitudinal axis and lateral axis. There won't be any bending of radio signal coming from the NDB station. Okay, so if the radio signal is coming along this longitudinal axis from westerly direction or easterly direction or north or south, there won't be any bending of radio signal. But if the radio signal is coming from some other direction, okay, it will suffer bending. So for example, let's say there is a radio signal which is coming at an angle of 45 degrees, which is coming at an angle of 45 degrees towards this aircraft. NDB radio signal coming at 45 degrees. So what will happen, because of this quadrantal error, this radio signal which is coming at 45 degree will be made to bend around such that it comes from, instead of coming from 45 degree, it comes from an angle which is less than 45 degree, 020, 030, whatever. The bending will happen in such a way to the extent that this incoming radio signal gets aligned with the longitudinal axis of aircraft. Again, if there is any other wave coming at from southeast direction, let's say 135 degree. So again, the bending will happen such that this wave bends around and gets aligned as much as possible with the longitudinal axis of aircraft. So instead of coming like this 135 degree, it will bend like this, and it will be coming at an angle which is more than 135 degree, 155, 175, whatever. Okay, at some angle which is more than 135 degree, right? If the radio wave is coming from this direction, 2 to 5 degree. So again, the bending will happen in such a way that this radio signal appears to be coming from at some other angle which is more or less aligned with the longitudinal axis of aircraft. So that angle will be, let's say, 190 degree. If it's coming from northwest direction, 315 degree, again the bending will happen such that the wave comes from an angle, let's say 345 degree, more than 315. So this is called quadrantal error. Okay. And the last thing is thunderstorm. Thunderstorm. What happens? Thunderstorm is nothing but lightning, static electricity discharges. This static electricity will interfere with your NDB ADF operation. And as a result, what happens is, if you are flying in an air mass which is dotted with this thunderstorm clouds, okay, you are flying in this particular air mass and you are surrounded by heavy thunderstorms cloud cells. The NDB, the ADF, sorry, correction, the ADF signal or the ADF instrument in your aircraft will point towards that thunderstorm cloud. It will point towards that thunderstorm cloud. So instead of pointing towards the NDB station, this ADF signal will point towards the thunderstorm cloud. So chances are, if the pilot is not aware about of this error, that is thunderstorm error to which your NDB ADF is exposed, pilot will track his aircraft towards the follow this needle indication and track his aircraft towards the thunderstorm cloud and find himself trapped in the amongst all thunderstorm cloud cells, right? So this is a very dangerous situation. So that's why this is called thunderstorm error. So the correct answer is, which one of the following disturbances is mostly likely to cause the greatest inaccuracy. So the greatest inaccuracy is caused by local thunderstorm activity. Remember. So first, a visual indication, the needle pointing towards the thunderstorm cloud, and the second is audio. You will hear a loud cracking sound in your speakers, microphones, or headsets because of this thunderstorm. Next, what is the maximum number of usable SSR transponder codes? So if you are using SSR transponder modes alpha and Charlie, the possible availability of codes is 4096. If you are using a transponder with mode S selective capability, the availability of codes is more than 1 crore. Okay, so here the most appropriate option will be 4096. They are talking about mode alpha and Charlie. Aircraft is 100 miles from a VOR facility. Assuming no error when using a deviation indicator, where 1 dot equals to 2-degree deviation, how many dots deviation from the center line of the airway will represent the limits of the airway boundary? So, here is your VOR facility. This is the center line of that airway. This airway is 10 nautical mile wide. That means 5 nautical mile on either side. And you are 100 nautical miles away. Somewhere here. Okay. And you have to find out how many dots deviation from the center line of the instrument will represent the limits of the airway. So this is your CDI indicator. This is the central dot, one dot, second, third, fourth, second, third, and fourth. So now this is a triangle, right? This is a triangle like this. So we will apply 1 in 60 rule formula. will be called track error angle, which is equal to distance off track divided by distance gone multiplied by 60. So distance off track is 5, distance gone is 100 into 60. So 5 into 60 divided by 100 is 3. So track error angle is 3 degrees. Track error angle is 3 degrees. Now we know that 1 dot equals to 2 degree. So 3 degree will be equal to how many dots? It will be equal to 3 divided by 2, 1.5 dots. So this 3 degree angular deviation will be represented by a serial needle shift of serial needle shift equal to 1.5 dots. So this is your dot number 1, and so the needle will be somewhere here. So this will be the indication shown to you. Okay. So if you get deviated to the left hand side, the serial needle will give the solution fly right. If you get deviated to the right hand side, the serial indication will be fly left. So it will move to the left hand side. But either direction, the dot answer, they have asked how many dots. So how many dots will it be? Left or right? 1.5 dots. Okay. Next. The middle marker of an ILS facility is identified audibly and visually by a series of what? So there are three markers: outer marker, middle marker, inner marker. So outer marker is blue, middle marker is amber, and the inner marker is white. Blue, amber, white are the colors. Morse code identification: outer marker is dashes, continuous dashes, 2 dashes per second. Middle marker is alternative or alternate dots and dashes, and inner marker is continuous dots. So the middle marker is identified audibly and visually by a series of alternate dots and dashes and an amber light flashing. So option Charlie. Dots and white light, so that is a signal, this belongs to inner marker. Dashes and amber light, we do not have this combination. Next. Aircraft is flying on a heading of 270. OBS is also set 270 with full left deflection, full left, and from flag displayed. Which sector is aircraft currently flying? Very easy. So let's say this is your VOR station. This is the north data. This is the radial 270. Right? Aircraft is accurately tracking radial 270 outbound. So what will be the representation on the OBS selector? So this is your aircraft, radial 270, tracking outbound, tracking outbound. So OBS will be OBS selection 270 and from will be indicated. If you are successful in maintaining the center line of this radial, the CDI needle will remain in the center, right in the center. Now in the question it's given that CDI has moved to the left hand side, right? CDI has moved to the left hand side, full left deflection. Now CDI, the job of a CDI is to give a solution. It gives solution to a problem. Now if the solution is left hand side, so the problem will be the opposite of that, right hand side. That means instead of instead of flying this radial accurately on the center line of this radial, your aircraft has deviated to the right hand side of it. So right hand side of this is this side. Going outbound, going outbound, this is your right hand side, this is your left hand side. Going inbound, this becomes your left, this becomes your right. But now we are flying outbound because it's written here OBS is set to 270 and you are getting a from indication. So you are flying outbound. Now flying outbound, if the CDR needle tells you to fly left, that means your aircraft has deviated to the right hand side somewhere like this. That's why you are getting a fly left indication. You are getting a fly left indication. Correct? So now in what sector are you in? So this is the north, this is north direction, east, south, west. So the direction between north and west is what direction? Northwest. So that means your aircraft has deviated in the northwest sector of the VOR. So correct answer is option Charlie. Aircraft is currently in the northwest sector. Next. ICAO specifications are that range errors indicated by DME should not exceed what? So the job of a distance measuring equipment is to show or indicate distances, land distances or ranges from aircraft to the DME ground station. Now these indications are not always accurate. So there is a defined limit, there are defined limits above and below which this DME equipment indication should not be relied upon. So those limits are plus minus 0.25 nautical mile plus 1.25 percentage of the slant range indicated by the equipment. So the correct answer here is option Charlie, plus minus 0.25 plus 1.25% of the distance measured. What is the metric distance of an NDB wavelength? So NDB works in the low frequency, medium frequency band 190 से लेके 1750 kilohertz. The wavelength corresponding to this frequency is kilometric. So option Charlie. Which radio frequency employs refraction properties of the ionosphere? That means we have three types of waves. The surface wave, ground wave, which follows the curvature of the earth. The second is sky wave. That means the ground station on the earth will transmit a radio signal in the direction of the sky. That radio signal will go up to the ionosphere and get reflected from it and come back to the atmosphere, to the ground surface of the earth. The third wave is the space wave. It's a direct wave. Space wave means this wave will directly go into the atmosphere and out of the atmosphere. It won't come back to the earth. So that is called space wave. Now, extremely high frequency and very high frequency, these two frequency bands employ space wave characteristics. That's why all aircraft operating this or getting or using this frequency bands or instruments working in this frequency bands must be in line of sight range of this ground stations. Then and only then they will intercept this radio signals, okay, which are going directly to the space. This is also space wave. So the only option remaining is high frequency wave, option Bravo. This high frequency wave will go up to the ionosphere and strike it and come back to the Earth's surface. Okay, simple. So this concludes our lecture. I hope you have understood all the questions I covered in this video lecture, especially the NDB ones and VOR questions. Very important practical questions. Practice them many times, practice them without looking for answers, explanations, and set the timer. See how much time you take to solve these questions. All the best of luck. I request you all to share this channel and video lecture with your friends. Subscribe if you haven't yet, and hit the like button if you have liked this video lecture. In my next lecture, I will solve the remaining 20 questions. So don't miss that. I hope to see you there.